Take me out to the ball game, take me out to the crowd. Okay, so we're looking at a projectile motion problem here for Unit 5. This is the C1 problem, 8.1, dealing with baseball. What we have here is we have a friend throwing a baseball horizontally, okay? So it's like perfectly flat. And he releases the ball at a height of 2 meters, and it lands 21 meters from his front foot, which is directly below the point at which he released the baseball. How long was it in the air, the ball, and how fast did he throw it? Okay, so first thing we do is we draw a picture of this, because this is like what is going on here? So let's just draw a picture, okay? Here is the ground, so whoop, a beautiful ground. And then let's draw your friend. They have a face, that's good for them. They throw the baseball here. It is 2 meters initially above the ground. So this distance here is 2 meters. And when they throw the ball goes, strikes the ground here. And this distance is 21 meters away, okay? And you know, a baseball's got laces. Woo, baseball. Okay, so how long was it in the air and how fast did he throw it? So how long was it in the air? This is a time we're looking for. And how fast did he throw it is a velocity. So let's take a look at what we have in this problem. Well, when we go and we look at our box, remember, in our box on the left side, we just need 2 out of the 3 things, the 3 things being the velocities, which for the initial and final for us will be the same. So 1, a delta x, 2, that's how far it went, and a time. Those are our 3 things. Our acceleration is always going to be 0 meters per second squared, because we're never going to have a rocket booster like accelerate an object in the x direction. We're just throwing objects and they're just acting in a projectile motion. Okay, so these are the 3 things we've got here: velocity, delta x, and time. We need also to remember that on the y side of things, if we have 3 out of 5 of the objects over here, of the 1, 2, 3, 4, 5, we can solve for everything else. And this is just given to us by our best friend. Okay, a series of kinematic equations. So let's just see what we have to start this problem. So what do we have initially? Well, we know that he releases it at a height of 2 meters, and it's going to fall those 2 meters. So we know how far it falls in the y direction. It falls 2 meters, and that's going down, so let's make that negative. Let's call down our negative direction here. Okay, so we'll call up positive, we'll call down negative. Now, we also throw this ball and it lands 21 meters to the right. So our delta x is 21 meters. Okay? Well, what else do we have? Well, we know that something's causing the ball to fall. That's gravity. Gravity has a value of 9.8 meters per second squared. And since it's acting down, we can call that negative. And what else do we have? Well, we know that your friend is throwing the ball horizontally, so it's perfectly flat. And if they throw this ball initially perfectly flat, they give it some velocity like this, none of this velocity is pointing up or down, which means that there is no initial y velocity. So our initial y velocity is 0 meters per second. Well, this is great. We've got 1, 2, 3 things on this side. Now, if we wanted to, we could go find the final velocity in the y direction, or we can go find the time. And it just so happens to be that time is something that we are actually looking for. So we just need to choose the correct equation in order to solve for the time here. If we take a look at this, we want to go back to our best friend. You know, don't forget about your best friend. It's sitting in our homework problems, and it's sitting in our objectives for this unit, and you should have a copy of it back from Unit 3 whenever we talked about them. But if we want to go back to our best friend, we can look, and if we have a delta x, we have a vi, we have an a, and we're looking for time, we actually want to use equation number 5 on our best friend to solve this. And this equation reads that delta x equals the initial velocity multiplied by time plus 1/2 AT squared. Oop, that's a 2 there. And remember, this is everything dealing in just the y direction. So this is like a y initial velocity, and this is the acceleration in the y direction. Okay? So, or we could just call that gravity because we know what it is. So if we go ahead and plug in some numbers here, we know delta x is -2. We know the initial y velocity is 0, so 0 times t is 0, plus 1/2 times -9.8 multiplied by t squared. Now we just need to solve this. You can do this algebra in many different ways. It's really up to you. I'm going to take the 1/2 and multiply it by the -9.8 to get a -4.9. So -2 equals -4.9 t squared. And then when I divide each side by the -4.9, my negatives go away. 2 divided by 4.9 is 0.408, which equals t squared. And if I want to get rid of that square, I need to take the square root of each side. So there's the root, it gets rid of that. And I find that t is equal to 0.64 seconds when I round that. So I have time is 0.64 seconds. So let's go back up to our box. Super important to use the box. And our time is 0.64 seconds. Now what's so amazing about time, and we've talked about this in some of the examples, is that it takes the same amount of time to go over as it does to go down, because our ball will in the end land right here, which means that the time it takes to fall, the 0.64 seconds, is the time it takes to travel 21 meters. So we have 0.64 seconds over here. And now when we look at this, we have two things. We can now figure out what the velocity he threw the ball at. Okay? And remember, this initial and final velocity are the same because in the x direction, it's independent of the y direction, and we're not accelerating. So if we can solve for this, it'll actually solve for both of them. On the left side of here, we could go back to our best friend, and on the left side of the box, because we only look at 2 out of the 3, we're always using equation number 1 here. And if we take a look at equation number 1 on our best friend, it is simply a constant motion equation stating that a velocity equals a displacement divided by a time. So in this case, we know the displacement. We can say here that the velocity is equal to 21 meters divided by the time, 0.64 seconds. And if we do 21 divided by 0.64, we get a value for the speed, or the velocity, which he threw it, as 32.81 meters per second. And yes, I'm ignoring sig figs and whatnot, but we're just doing everything to the idea here. Okay, so now I can go back up to the box and I can say, hey, look, I have this value for both of them. It's 32.81 meters per second. And that's it. We had part A over here on the left side and part B over here on the right. And that's the whole problem. We drew a picture, we recognized what we had in it, and then we just started filling out this box. We recognized that we had 3 out of 5 things first on the right-hand side, so we used it to find time. We moved that time over to the left. Then we had 2 out of 3 things to solve for the x components and directions. And that's just how we do these problems. If you wanted to, you could go ahead and solve for the final velocity in the y direction. We could do that. Like, there's another equation on our best friend that would allow us to do it. But we didn't really care for it in this problem. It wasn't really something we needed. So we just didn't bother. Okay, so that's just one way to do a horizontal motion problem. We're going to see another example of Luffy and some friends on the Going Merry shooting a pirate cannon. But these are just horizontal velocity problems, and the big thing to just recognize is that you're using the box, and that for a horizontal problem, the initial y velocity has to be 0. Okay, so I hope that helps you out. Hope you enjoyed it. But this problem, for now, is finished. So adios, and y'all take it easy.